All right, we have an A2779 in for board repair, reported as liquid damage, and really looks pretty clean to me. I don't really see any signs of liquid damage in the chassis or on the board. There could be something hiding under a sticker or something like that. Happy New Year, everyone. Let's get to it. Enough preamble. It's maybe a little bit late to say Happy New Year at this point. Came back from a 2-week trip to like 7 MacBook board repairs to do. Unfortunately on those I didn't record most of them because I just needed to get work done. But I'm through all of our quickish ones now. So, well, this one very well might be quickish, we'll see. Oh boy, I sure hope this has a single bad ceramic capacitor. That would make my life easy. Let's see what MacBook does. So, I already have a connector out. We plug it in. 5 volts and ooh, quite a bit of current. Unplug this. So something like this is drawing enough power to where we very well might just see our problem with a thermal imager. So let's use that because we have that tool. It's expensive, but it sure is helpful. Will save you a lot of time quite often. It could also misguide you, but probably not. Okay, let's kind of get this in rough focus here. What is... Oh, ow, that's not good. So maybe our small PMU. Let's take off that sticker and look. Ow. Well, simple diagnostics here, but annoying repair. I believe I have an M2 donor I can pull this from. This might be the first time I've actually seen this fail. The small PMU. I've seen the big PMU dead quite a few times on these. No corrosion here. Perhaps somewhere on the back of the board. I kind of want to see what caused this because I doubt it just kind of died on its own for no good reason. Okay, what are we looking at? Perhaps 3V8 AON PMU. Now that chip's getting quite hot. I would really think that it's bad. I do maybe just want to directly inject voltage into the line before I go ahead and just replace the PMU. Yeah, so 3V8 AON PMU short. Let's go ahead and solder a wire to that line and just send voltage into it directly to make sure it's not some other thing causing this. Just because something gets hot doesn't mean it's bad. That is getting pretty hot, and in one exact spot is almost certainly bad. But it might not be, and replacing the PMU is a pretty involved project. So we don't need to do it. We shouldn't. Where's my easiest spot to solder a wire? Probably on the back of the board. Okay, we'll do that. Looks like I already got some smolder on this. Grab a pair of tweezers. Hold that down. All right, and let me set up my little voltage injection. All right, this is a 3V8 volt line. Okay, let's see what that does. It probably is just bad chip. I think we kind of have like a partial short on this line, and there's going to be some other supplemental rail on the chip that's like dead short, but okay, let's let's see what we're seeing here. Sad. Dead. Bad. Do I have time to do this right now? I think I do. I'm gonna go for it. Let's get our wire off, and then we'll remove this this chip. I think I'll go ahead and actually I'll put this on the preheater. I think that'll make my life a little easier. Let's set all that up. We'll be back in a moment. Okay, so we just have the board on a preheater. We already have a reballed chip ready to put on here. I have the preheater at 170 or so, which probably is going to have the board at like 150, 160 because it's elevated off of it. Having the board aggregately heated with a heater for a larger chip like this is just going to make your life a lot easier. I've also got a little vacuum tool I've been using for larger chips, so we're going to use that here. You can also do this if you just have a pair of like hooked tweezers or something like that, but really, well, here, this sort of thing here. It's just like a handheld little vacuum pump with the suction thing. It's maybe 40 or 50 bucks, something like that. Maybe I'll start putting that in the description under the tools we use links. In any case, I'm still just going to be at 430, 120. Let me get the your chip out of the way. I'm going to set that aside. We'll grab it once we're ready and this board's clean. This will also make, like, wicking off the solder pads here easier, that sort of thing. But having the board just aggregately hot like this, we're going to be able to just do, essentially use less heat with, hot air to get the chip off, essentially. Still pretty on there. And boom, comes right off, easy peasy. And that's just a much, you're less risking, knocking components in the area. So something like this where there's a bunch of things really close to it, and it's a pretty big chip to where most tweezers are going to kind of be too narrow to grab. This just works well. Let's get leaded solder on all these pads and then just wick the area. With the board hot like this too, it's going to be easier to wick because the iron has less mass to heat up. Well, it has the same amount of mass, but it's already warm, so you can kind of get by with using like a micro pencil or something to wick this area, which just is much easier to deal with. Get the fume extractor on, get a little bit more flux on there, and then we'll get leaded solder on all these pads, wick it, and then we will get our new chip on, which will also be easier because the board is already warm with the preheater. Big, this is a sponsorship for Big Preheater. I'm using some Puhui, I don't know, Puhui J8280 because it was sold on Mobile Centrics in the US, so I got one. I'm not sure if I've actually shown this in a video before. Use bigger iron. It's just a little bit finagly with the micro pencil. Use hot air to get that. Okay. So we maybe lost a no connection pad there. Okay. Oh, what are we looking at here? All right, no connection. We don't care about that. Goes nowhere. Okay. Okay, let me do some hot air. Go to like 345 in this case. see. I'm just going to do a little bit of assistance with the hot air here to get these like ground pad corners that are kind of stubborn. Okay. And I'll reposition again. Shaky hands today. And then I just want to get this. That's looking pretty clean. Let's get new flux on there and get the chip on. Again, big chip like this, you really don't want to use a lot of flux. Think of it like you just want a thin layer. That covers all the pads. That should be fine. Grab new chip. Pin 1 is going to be our lower left. That's looking pretty where it's supposed to be. So we'll do the kind of classic sneaking up on this. 430, 120, board's preheated. We'll start from far away. Zoom in a little bit more. we can see the chip kind of swooped into place. I'm gonna let the hot air go a little bit longer. And we'll remove heat. I'm gonna turn off the preheater and let this board cool down for a while. And then we will see if it works now. I sure hope so. I guess we can check our 3V8 short was gone. Let's see. Yippee. No more short on 3V8 AON. Okay, well, we'll let this cool down, then we'll test it. It's at a normal temperature. Okay. It seems like it's working now. I already checked. Beforehand. And then I pretend to be surprised. So we plug this guy in. All right, we're getting 5 volts, normal. Current climbs up, cool, 20 volts, hooray. This seems to be on. So let's put it back together and make sure it works. I don't think data was important on this one. They're trying to get a working machine because they had a fancy M2 Max that's expensive. So put it back together and make sure it's working. I think so. And then we'll break it down for you. Kind of go over an issue summary. As we can see, it's not just for show. The MacBook is indeed working. It's kind of brief summary on our issue here. I forget what kind of voltage we were getting on the onset, but it was getting, what, I think 5 volts high current. I'll put a correction on here in text if that's wrong. But fundamentally, this came in. It was reported there was liquid damage, and then it stopped working. I saw no signs of liquid damage anywhere on the device after looking at it quite thoroughly. What seems to happen here is just the small PMIC kind of killed itself internally. Why that might have happened, not sure. But effectively it was shorting out 3V8 AON. Chip bad, replace the chip, it works. So we did see thermal signaling on this chip just running power through USB-C, but just because something is getting hot, especially when you're running power through, like, you know, a Type-C connector or just DC in jack to a whole device, a lot of things might get warm. That doesn't always mean they're bad. This was kind of getting to a concerning temperature, which is a pretty good sign it's bad, but you can be, you know, certain on that if you inject voltage directly into the line. That is, you know, where your short circuit is. If you're seeing that, you know, get hot there, well, there's your problem in any case. And if we did have, you know, a capacitor that was actually causing our issue and we injected voltage directly into the line, we would see that capacitor get hot. This is something you can sometimes see on some sorts of power rail shorts. You might see like a chip getting hot. I think a good example actually is something like, you know, like a VDD main short on an iPhone 8. Bit of a classic for you, or like iPhone 6, 7, 8. There was a little MOSFET chip that would get hot if you sent power directly into the battery when it had a VDD main short. But if you were inject voltage directly into the line, you would find typically a ceramic capacitor causing your problem. So, you know, the thermal signaling can be misleading, but it's always, well, most of the time it's gonna, you know, point you in the right direction, or it can, I suppose, if you know what you're looking for. That's pretty much it. I'll write what the USB-C behavior was on here, but it's effectively a 3V8 AON short, dead A2779, or, you know, small power IC is kind of what it's colloquially known as. Normally you see the larger PMIC fail, and it's more just these tend to get liquid damage in this area or on the back side of the board right here, which will then kill that big PMU. It's pretty rare for them to get any corrosion kind of in the middle section of the board, including this area. I know, like, for me, this is the first small PMIC I've seen bad. I think at least on M2, maybe I've seen like one M1 board some long time ago, but definitely for none of like M2, M3, M4, haven't seen any of these with a dead small PMIC. I'm sure some other people have, of course, but in any case, I would imagine this might be helpful for someone somewhere. And if it does help you, make sure you like and subscribe and send me your dead MacBooks so we fix them. And we will see you next time I feel like recording and editing a board repair video. Happy late, very late New Year, everyone.